You're watching a fireworks display on New Year's Eve. Colors explode across the sky. Red, green, gold. Each burst travels faster than sound, painting the darkness for a split second before vanishing. You've seen this show 100 times, but you've probably never thought about what's actually happening up there. But here's something that might surprise you. The explosive force lighting up that sky comes from a mixture invented over 1,000 years ago. 3 simple ingredients. Mixed in the wrong ratio, nothing happens. Mixed correctly, you get one of the most influential inventions in human history. And the people who discovered it were actually trying to live forever. The story of gunpowder begins in ancient China, around the 9th century. Taoist alchemists were obsessed with finding an elixir of immortality. They experimented with everything: minerals, herbs, and strange chemical combinations. One recipe called for mixing saltpeter, sulfur, and charcoal. The result was not eternal life. It was an explosion that burned down their laboratory. Then accidents turned into engineering. Chinese inventors realized this volatile mixture could be weaponized. By the 10th century, they had created fire arrows, bombs, and early rockets. The formula eventually traveled along the Silk Road to the Middle East, then to Europe by the 13th century. Within 200 years, gunpowder had transformed warfare, politics, and the entire course of civilization. Castles that stood for centuries crumbled. Armored knights became obsolete. The world would never fight the same way again. Here's the thing nobody tells you. Gunpowder is deceptively simple. Just 3 ingredients in precise proportions. Potassium nitrate, also called saltpeter, makes up about 75% of the mixture. Charcoal accounts for 15%. Sulfur fills the remaining 10%. Change these ratios even slightly, and the powder either fizzles or becomes dangerously unstable. The production starts with sourcing raw materials. Historically, saltpeter was extracted from decomposing organic matter, manure pits, cave deposits, and even scraped from stable walls. Today, it's manufactured chemically or mined from natural deposits in places like Chile and India. The crystals must be pure white, free from contamination. Charcoal comes from burning wood in an oxygen-limited environment. Willow, alder, and grapevine produce the best results. The wood is heated to around 300 degrees Celsius until only carbon remains. Good charcoal is jet black, lightweight, and crushes into fine powder between your fingers. Sulfur is mined from volcanic deposits or extracted as a petroleum byproduct. It arrives as bright yellow chunks that smell faintly of rotten eggs. The sulfur gets ground into powder so fine it feels almost silky. The mixing process is where chemistry becomes dangerous. Each ingredient is ground separately first. Then they're combined using wooden or bronze tools, never iron, which could create sparks. Traditional methods used a ball mill, rotating drums filled with lead, or bronze balls that crush and blend the powders over several hours. Water or alcohol is sometimes added to create a paste, reducing the risk of accidental ignition. The wet mixture is pressed into cakes, dried, and then broken into grains. Grain size matters enormously. Larger grains burn slower, suitable for cannons. Finer grains burn faster, ideal for rifles and pistols. Modern military-grade gunpowder undergoes additional steps. The grains are tumbled too round their edges, then coated with graphite to reduce static electricity. The final product flows smoothly, ignites reliably, and stores safely for decades. But wait, the surprises keep stacking. Gunpowder doesn't actually explode in the traditional sense. It deflagrates, meaning it burns extremely fast rather than detonating. The reaction produces massive volumes of hot gas, nitrogen, carbon dioxide, and sulfur compounds, expanding to roughly 3,000 times the original volume in milliseconds. That rapid gas expansion is what launches bullets and rockets. The color in fireworks comes not from gunpowder itself, but from metal salts added to the mixture. Strontium creates red. Barium produces green. Copper makes blue. The gunpowder simply provides the lift and the bang. And here's something even stranger. The loudest part of a firework isn't the explosion. It's the shockwave created when gases heat air to over 2,000 degrees Celsius, faster than sound can travel. Here's where the story flips. Despite being invented in China, gunpowder was eventually perfected by European chemists who standardized formulas and manufacturing processes. By the 1800s, Western nations controlled the global gunpowder trade. China, the country that invented it, had to import gunpowder technology back from the West during the Opium Wars. The invention that defined Chinese innovation for centuries had been reverse-engineered and industrialized by others. Next time you watch fireworks, you have 4 facts worth sharing. 1. You're witnessing a chemistry experiment from the 9th century. Alchemists searching for immortality accidentally discovered one of history's most transformative inventions. They wanted to live forever. Instead, they created something that ended countless lives. 2. The explosion isn't really an explosion. It's extremely fast burning that creates gas expanding 3,000 times its original volume in milliseconds. Real explosives detonate. Gunpowder deflagrates. Different physics entirely. 3. The colors have nothing to do with gunpowder. Each hue comes from different metal salts, burning at specific temperatures. Red is strontium at 600 degrees. Green is barium at 500 degrees. Blue is the hardest to achieve, requiring copper compounds at precise temperatures. 4. Count the seconds between flash and boom. Every 3 seconds equals 1 kilometer. You can calculate exactly how far the explosion is. That last one especially. People love doing the math in real time. So next time the sky lights up, you'll see more than pretty colors. You'll see 1,000 years of chemistry, warfare, and human ambition compressed into a single flash. That's the process. We reveal how things actually work, one story at a time. If there's something you'd like us to explore next, let us know. Until then, trust the process.